For years, tracking artificial intelligence was a highly predictable science. Researchers used standardized evaluation benchmarks to measure language models, plotting steady, incremental improvements on clean, predictable graphs. This graph charts the respected METR evaluation scale. On May 12, 2026, the trendline for Anthropic's Claude Mythos model shoots up, literally breaking past the y-axis. This represents Mythos achieving a 50% success rate on complex cybersecurity operations, tasks taking human experts 16 continuous hours. Just a few years ago, the most advanced models struggled to maintain context on instructions that took only a few seconds to process. As AI shifts from a passive text generator to an agent executing 16-hour autonomous missions, it is testing the structural limits of how we measure intelligence. When a model breaks a primary benchmark's upper boundary, researchers are forced to develop entirely new metrics to find where its capabilities actually end. The first major barrier to fall is the operating system itself. Historically, software programs needed highly specific back-end APIs to talk to each other. That requirement is gone. The open-source ecosystem OpenClaw recently released an update called Peekaboo version 3. This technology effectively gives an AI the eyes and hands needed to perceive and manipulate a local desktop environment. Watch how this works. The AI looks at a standard macOS screen and analyzes the spatial relationships between individual windows, buttons, and text fields. It doesn't need to read the underlying source code to understand what a search bar does. Because it can see the desktop, the agent can execute multi-step routines across entirely different local applications, navigating the interface exactly like a human knowledge worker. The browser is no longer a sandbox. For the first time, a cloud-hosted model can interact with a local file system or a proprietary application, as if it were a local user. Meanwhile, in China, tech giants are plugging these autonomous agents directly into massive, closed-loop commercial ecosystems. Alibaba recently hit a major milestone by fully integrating their Quen AI model into the underlying architecture of the Taobao shopping application. Instead of typing a few keywords into a search bar and scrolling through pages of results, a user can type a highly specific, multivariable request in natural language. The AI takes that prompt, sifts through 4 billion products, compares historical pricing data, and independently executes the transaction. Tencent is applying this exact same autonomous logic to enterprise workflows. Their QClaw system acts as a bridge, breaking down data silos between local desktop files, collaborative team documents, and cloud-based knowledge repositories. These systems have evolved past passive advisement. They operate as autonomous economic actors capable of reasoning through and executing multi-step commercial and collaborative transactions. To truly understand why these capabilities are accelerating so quickly, we have to look beneath the software applications, down to the foundational architecture of the models themselves, specifically recent research out of METR. Since the beginning of large language models, developers have relied on a tool called a tokenizer. It acts as a strict translator, slicing human language into specific, predefined chunks so the neural network can process them. But a tokenizer becomes highly inefficient and rigid when it is forced to process noisy, non-text real-world data like raw audio files, dense codebases, or complex structures. This animation illustrates Meta's breakthrough, the Fast Byte Latent Transformer, or BLT. This architecture completely eliminates the need for a tokenizer. By dropping the translator, the AI ingests raw data bytes directly. It uses a mechanism called dynamic patching, organizing the incoming information based on data entropy, or data weight, rather than strict human language rules. By removing the need for a predefined vocabulary, the model can ingest any sequence of bytes, from obscure programming syntax to raw sensor data, without the distortion of a middleman. We now share our digital environment with agents capable of executing 16-hour cybersecurity tasks, controlling our local computer desktops, and finalizing complex economic transactions. For knowledge workers and business leaders, watching these technical barriers fall creates a very real sense of anxiety about skills becoming obsolete. To put this into perspective, we can look to NVIDIA CEO Jensen Huang's recent commencement speech at Carnegie Mellon University. Huang argued that autonomous AI doesn't replace human ambition. Instead, it eliminates the technical friction that historically held people back. effectively leveling the playing field for everyone. Silicon Valley investor Jaya Gupta takes this idea even further with a concept she calls the organizational moat. Gupta argues that as AI begins to automate the routine labor of technical execution, handling everything from data cleaning to writing and testing code, the competitive moat shifts. When technical output becomes faster and cheaper to produce, a company's edge becomes its shared identity and the quality of its strategic decisions. Dismantling these digital boundaries resets the starting line. It provides anyone with a clear strategic vision the tools to build and execute without the traditional friction of specialized tech.